What I'm about to show you here is one of the very common things that I get pulled into in the Cisco Customer Proof of Concept Lab in association with the Spirent TestCenter traffic generator. So it's very common that someone might come up to me and actually tell me that they can't get their Spirent TestCenter to get working multicast between the source and the receiver. One of the first questions I'll typically ask, of course, is, are you doing any source multicast or source-specific multicast? Sometimes they don't necessarily know what that means, so another way I might ask it is, are you using a rendezvous point, or are you doing the type where you know exactly who the source is and you're not using a rendezvous point? Use of the rendezvous point would be back to any source multicast, and no use of the rendezvous point but still being in sparse mode as opposed to dense mode would be what's known as source-specific multicast. If they still don't necessarily know, I'll just go ahead and go right to them. Key difference here is that the Spirent TestCenter will send an IGMP membership report when it's trying to join. If what they're trying to do is go from the left-hand side where I have a Spirent TestCenter being a multicast transmitter to router A being the first router that sees multicast traffic, so that would be the first hop router. It's the first router that sees multicast traffic. The last hop router would be the last router that sees multicast traffic. That will be connected to a receiver. In this situation, a Spirent TestCenter host acting as a receiver. So we'll go ahead and have these IP addresses. So 10.1.1 is between the source and the first hop router. 10.1.2 is the subnet in the middle, using OSPF as the IGMP here. And PIM, I have PIM neighbors. I'm doing PIM sparse mode here, as well as here and here. And on gigabit 106, I have another Spirent TestCenter port connected on subnet 10.1.3. Now, the first and foremost thing to remember is that sparse mode multicast as opposed to dense mode multicast. Sparse mode multicast is a pull technology. It needs some type of trigger for the multicast to actually start getting pulled down. So what we're going to go ahead and do is to look for the trigger, which means I'm going to troubleshoot here between router B and the Spirent. This is where I always start whenever I'm doing source-specific multicast, because if the last hop router does not see the trigger, the request to start a multicast distribution tree and pull the traffic down to it, then all bets are off. So we're going to go ahead and start on router B. I'm going to go ahead and come over here. I'm typically going to do a show IP mroute. That's one of the first things I'm going to do, and we'll just go ahead and move this up here for right now. Move this down a little bit. Actually, I guess we'll just move this over a little bit. And again, what you're looking for is you're looking for this device as well as router B over here. You'll see that we have the multicast address 224.0.140. 224.0.140 is one of the auto RP multicast groups enabled by default. So we're going to go ahead and we're going to see that in there, and that's not the one that we're interested in. How do we know that? Because I've talked to the customer, and also you wouldn't be using that one. Now we're going to hear that we're doing an IGMP membership report again from gigabit 106. Now router B will actually ignore IGMP membership reports from any devices off of gigabit 106 unless it's programmed to pay attention to them. You can program it to pay attention to them in one of two ways. The most common way that I use is you actually enable PIM, protocol independent multicast, to be on that physical interface. Another way is you can actually just turn on some kind of just IGMP. If your theory is you're never going to have another router out there, please don't do that. So unless you really are a specialist in multicast and know what you're doing, please don't ever do that. So we're going to do a show IP PIM interface, and what's going to happen is it's going to show us that everything looks pretty good so far. Router B actually has PIM enabled on the interface, protocol independent multicast enabled on the interface towards Spirent. With PIM enabled on the interface towards the Spirent or the receiver, we should be picking up IGMP membership reports. So there's also PIM protocol independent multicast going between router A and router B. But let's go ahead and figure out what's going on. So if we do a show IP IGMP group, all we see is the 224.0.140. Typically what I'll do here is I'll go right to reality and see what their Spirent TestCenter is set up as. One of the things I'm probably going to do is actually make sure that they're connected to the same device. I don't want to spend a lot of time and energy. So this says it's router B. So if I actually come here and I go over to this telnet session to router B, and if I do a config T and go into what in theory is gigabit 106, I'm going to go ahead and shut this down. The reason why I'm shutting this down is because I've been burned a lot, where accidentally someone has misdone the cables or whatever, and I don't want to have to go through that. So prior proper preparation and all on the troubleshooting perspective. So I'm going to make sure I'm actually going to be troubleshooting the right interface. So router B, gigabit 106. This router B right here is a green interface. I'm going to go ahead and do a shut, and you'll see that it turns gray. So yes, that is indeed the right interface. So let's go ahead and do a show run interface gigabit 106. Well, I think I'm in subnet 10.131. and PIM Sparse mode is on, and this Spirent TestCenter thinks it's in 10.130/24 with 10.131 as its default gateway. In fact, we should be able to ping the default gateway and find that the ping works perfectly fine, as you can see from the ping. So everything was perfectly fine, no packet loss. So we're actually doing perfectly fine. If we do a show IP ARP, we'll actually see that 10.1.3.101 just came in trying to ping us. So we're good, and it's out gigabit 106. So okay, so why is the IGMP not working? Now hopefully they actually learned and figured out that they actually had to come up to technologies in order for the IGMP tab to show up here. So you'll see right now that it's a non-member. Maybe they didn't realize they had to activate it. So let's go ahead and activate it. So they've already come in here and said that router B is supposed to be active, it's supposed to be doing IGMP version 3. IGMP version 3 is the one where you can go ahead and say, this is my specific source that I would like to join, which is 99% of the time what people are trying to do when they come into CPOC doing source-specific multicast. It's very rare that I see anything else being done. So we're going to go ahead and do IGMPv3 here, and we'd like to send a source and the multicast group, so we don't need a rendezvous point to actually hook the source and the receiver up. They can do it on its own, because with the IGMPv3, the receiver knows exactly who it wants to talk to. So let's go ahead and edit this. So it's an IGMPv3 for 232.1.1.1. So if we actually look in here, show run include SSM, router A, and we can look at router B, and we can look at router A also, is configured such that the source-specific multicast range is supposed to be the default. IANA has the default as 232/8. If we go ahead and take this command and copy it and move over to router A, that's also 232, the default 232/8. Now, even if router A had not had this on here as the SSM for the default range, this wouldn't actually be causing a problem right now, but usually while I'm in here, I'm trying to get to the next step and make sure that everything's okay. So if I do a show IP IGMP groups, we don't actually see anything except for 224.0.140. So what we're going to do now is we're going to go ahead and go back over here. We're going to do a capture. So we're going to, on the Spirent TestCenter, you can capture the control plane traffic that's going out on the interface. And then we're going to go to the device, and we're going to tell it to send a report for the IGMP groups. So it goes from non-member to member. If we come back over here and look, did we receive anything? We did not. Let's do a show IP mroute, and we still didn't see anything. Let's do a debug IP IGMP groups, or a debug IP IGMP, and then hit enter. And let's do a config T logging console. Do have a little power supply thing going on that might happen. Let's go ahead and try to redo it. So we just resent the report, And what's really strange is we're actually saying that it's going to get ignored. So why is it getting ignored? Let's go ahead and stop this. Come over here and look, stop this, and look at this. So if we actually come here, it's very interesting because what you'll actually see is that it looks like we're trying to send an IGMPv2, which is really very fascinating. But it really should be an IGMPv3. Now this is something that I've also noticed, so let me just go ahead and close that. So that's something that I've noticed sometimes where it has some kind of backwards compatibility. So what we're going to do now is we're going to go ahead and come over here and we're going to do a show IP IGMP interface gigabit 106. And what we'll actually see on here is that we want IGMPv3 to be sent, but IGMPv3 is actually not getting sent out. So let's do a config t no logging console. So look, the host version of what we're supposed to do is a version 2. The router version is a version 2. So the end device is actually seeing an IGMP version 2, and whether it should or should not, it's trying to send the IGMP version 2 as opposed to an IGMP version 3. So one of our first issues is that there's backwards compatibility. So what we should do is on this physical interface, we should do an IP IGMP version 3. And let's go ahead and do an end. Okay. And let's go ahead and save that. And apply this. Now a question for you. We've changed over on router B. Let's do a show run interface gigabit 106. So we've changed over on router B on the physical interface that's connected to the receiver to support IGMP version 3. Should we also do that on the physical interface between router B and router A? And should we also do that on the interface on router A that's connected to the source? The answer is no. The IGMP membership report is actually between the last hop router and the receiver. It's something that receivers send and goes on between the last hop router and the receivers are. Protocol independent multicast will work between router B and router A, and as long as protocol independent multicast is enabled on the physical interface on router A to the multicast source, then router A has been essentially programmed to pick up that multicast traffic. So now if we do a show IP IGMP interface gigabit 106, you'll see that now we're supposed to pay attention to IGMPv3. So let's go back over to our Spirent and do a capture. And let's go ahead and we see that we don't have a membership right now, so let's go ahead and start it. We go from member to non-member by starting the control of sending an IGMP version 3. And we'll just go ahead and come over here and do a capture since I already know what's going to happen. So let's do a show IP IGMP groups. Now it's very interesting, right? There's no multicast, so that 232.1.1.1 is not in there. So if we do a show IPM route, it's still not in there. So it's very interesting. What this really has to do with, if we look at the multicast that was actually being sent, it really was an IGMP version 3. So it's going from the Spirent TestCenter 10.1.3.101 to 224.0.0.22. It's an IGMPv3 membership report. If we look at the IGMPv3 membership report, it's actually what is called Exclude Mode. A lot of people think of IGMPv3 as here's the source that I would like to join and here is the multicast group I would like to join. It's actually a lot more complicated than that. The Spirent TestCenter, and I'm not too sure why, defaults to exclude mode with a number of sources as 0. So if you actually look, if we change this, if we come up here, and this is typically what it always is, when I come up here and I see this, really what they want to do, if we look back over here, they want to join the multicast traffic from 10.1.1.101 going to 232.1.1.1. So we're not saying that. So we're going to change it from the default of exclude mode to include mode. Now when we do that and we scroll over to the right, what you'll also notice is user-defined sources. So there's 3 things that we have to do on this page. 1, we have to change it from exclude mode to include mode. Number 2, we're going to say that we want to define who the sources are. Number 3, we're going to put the source 10.1.1.101, which is our guy right here, 10.1.1.101. We're going to put that up here, and we're going to say OK. We're going to click Apply, which means push these configs out to the Spirent TestCenter appliance. We're going to go ahead and do a capture here and see what the difference is between those. And then we're going to go ahead and say, please go ahead and send that again. And we'll come over here. And we'll stop this, and we'll come over here, and what we'll see is now we actually see the IGMP membership report in the multicast routing table of router B, the last hop router. We can also do a show IP IGMP groups, and we see 232.1.1.1 here. We can even do a detail, and we can see that it is a 232.1.1.1. It's flagged as SSM. It's an include statement. The last reporter was 10.1.3.101. And that receiver right there said, I would like to go ahead and get multicast from 10.1.1.101 as long as it's sending to the group 232.1.1.1. Now let's go ahead and look at what that actually looked like. So here is the IGMP membership report that it sent. And now instead of an exclude, it is a group record 232.1.1.1. And I would like to specifically join anything. The number of sources is 1. You can actually put a source list in there as well. 99% of the time, what we're doing is number of sources is 1. So typically we're doing include, user-defined sources, 1 IP address. That's 99% of the multicast IGMPv3 that I tend to see. So we're going to go ahead and have this be the source and this be the multicast group that it's trying to send. So we'll go ahead and quit out of that. Do a show IP mroute. And now someone may say, well, I'm not necessarily getting the traffic. But what's going to happen is if you see this small s here, the small s actually means that we do recognize it as source-specific multicast, because source-specific multicast up here will be a little s as well. Let's go over to router A, because it should actually be going to the incoming interface of 101. So if we do a show IP route 10.1.1.101, it should be out that interface. If we do a show IP RPF, and that might not be the right command. It is. So show IP RPF, I'd really prefer if that said show IP PIM RPF, because we're not asking for the unicast reverse path forwarding neighbor. What we're really asking for is the PIM reverse path forwarding neighbor. So the neighbor being the PIM reverse path forwarding neighbor. So we know that this is all perfectly fine, so it's all properly formed. So we would send a PIM s, g join, show IP mroute. One of the strange things for me is when I transitioned and started supporting and troubleshooting source-specific multicast is actually that usually when it's any source multicast, you will not see the s, g in the first hop router connected to the source unless the source is actually started. With source-specific multicast, because it doesn't need the rendezvous point to go, it will actually send an IGMPv3 membership report with the source and the group. And then as long as all the routers in between support that multicast group as source-specific multicast, you don't need a rendezvous point. You'll go ahead and send a PIM S(G) join all the way to the first hop router. It's very interesting because if you actually do this and do a count, you'll notice that there is no traffic forwarding at all. It's very common with SSM, and it was very unusual and odd for me at first. All this really means is that this interface, this multicast source, is not online yet. Again, something just very strange and unusual when you're used to ASM, any source multicast, because again, the S(G) does not show up in the first hop router unless the source is actually sending. But as you can see, we have no source traffic. So we're going to go ahead and come over here to the Spirent TestCenter again, and we're going to say that router A is going to go ahead and it's going to send to this group. And we're going to add this, and then we're just going to go ahead and do next. We'll leave it at 128 and next, and we'll leave it without a header. We could change it to a UDP header, and then we'll do 1000 frames per second. And finish. And then we're going to again apply the instructions that we have on this GUI out to the appliance. And then we're going to go ahead and we're going to start the traffic. Now when we start the traffic, what we'll see down here is that I did ask for it to send at 1000 frames per second. Yep, let's start the traffic, not just an ARP. So router A is going to send 1000 frames per second, and router B, the Spirent TestCenter port behind here, is going to go ahead and receive 1000 frames per second. So this is the router A, Spirent TestCenter, which is generating 1000 frames per second because it's going in this direction from the Spirent TestCenter to router A. Router A is sending that traffic across the physical interface over down the multicast distribution tree, the S(G) to router B, and router B is sending 1000 frames per second out to the Spirent TestCenter. So if we go ahead and we're good to go here now and do a show IPM route, what we would notice is that now there's actually also an incoming interface. If we look up here, it's very fascinating because there was an incoming interface up here as well, right? So you're like, well, what's the difference? The difference actually is right here on the count. We are indeed actually sending traffic. How do we know that? Because we asked for a count. This is forwarding. This is the packets count. This is the packets per second. You can see that we're actually sending 1000 frames per second. So if we do a show IP mroute count, and this is the packets received, and if we go over here and do a show IP mroute count, we're actually bringing the traffic in, and it's actually going right at about 1000 frames per second out over here. Another thing I'd like to show is if you do a show interface gigabit 106, you can also see that the multicast traffic has come up here. We can see that the traffic that's coming in is multicast traffic because really it's pretty much in sync with everything that is actually coming in on the physical interface. So again, most common thing is right here on the Spirent TestCenter. What you'll need to do is you'll need to come in here and you'll need to change this from an exclude to an include. You'll need to move over here, do user defined source, and then identify what source you're trying to get to. And then go ahead and try your Spirent TestCenter again. Have a great day.